And we're back with 8.5. Yesterday, or last time, whenever it was, we talked about polygons and how to find the measure of one angle in a regular polygon, or how to find the total amount of degrees inside of a polygon of any number of sides, right? A 27-gon, etc. Today we're going to talk about congruent polygons. Congruent is a fancy word for exactly the same as. Exactly the same as. So let's get into it. Congruent sides, if one side is exactly the same as another side, well, then obviously they're going to have equal lengths. And if one angle is exactly the same as another angle, they're going to have equal measurements, right? Now, we have a different symbol, and you need to pay close attention to this, for congruent. And that's the symbol for congruence. Why did we have this other symbol? Why not just equal? I'll tell you why. Excuse me. The reason is that in math, the symbol equals we use for saying this number or this amount, which we usually use as numbers, is equal to this amount. But if you're talking about shapes, or you're talking about lines, that's not an amount. That's an actual figure, right? So we say this shape is exactly the same as, or it's congruent to this shape, or this line is congruent to this line. Now their measurements might be equal, like one is 8 centimeters, but that's an amount. And that's equal to 8 centimeters, and that's an amount. So we can use the word equal. But if you're talking about the actual geometric figure, then you use congruent. So let me give you an example of that. So check out these two triangles. This statement right here is a congruence statement. Triangle KLM is congruent to triangle PQR. And so if these are congruent, these are little congruence marks here. So line LM is congruent to line QR. See that? So you wouldn't say line segment LM is equal to line segment QR, because line segment LM is a figure, it's not a number. Is that making sense? So we use the congruent symbol. It's congruent to it. Now you might, okay, so let me leave it at that. So right now, if these two triangles are congruent, then this angle is 80 degrees. There's a corresponding angle in here that must also be 80 degrees, and it's up there, right? And M corresponds with R. Now watch this. Boom. Let's pretend I was going to name this triangle, triangle KLM. So just going KLM, triangle KLM, boom, is congruent to, and I just went over on the bottom left, up to the top, and then bottom right. If I did the same thing over here, bottom left, RQP, triangle, RQP, this is not correct. Because K corresponds with what point over here? What vertex? P. So K is listed first here, but P is listed last here. If this one's first, and this one's first, that I've listed here, then I'm saying K corresponds with R, and L with Q. L, Q, well that got right. And then M and P, but M and P, no, that's not right. So, the correct way, look at me, the correct way to name one polygon congruent to another polygon is to list the vertices, vertices, in the correct order, so that you have this vertex first here and its corresponding vertex first over here. So let me give you another example of that. And it'll actually show you right here in example 1. Okay. By the way, when you're naming a polygon, if it's a triangle, we use that nifty little triangle symbol. You know, triangle, ABC, whatnot. But if it's something more than triangle, a quadrilateral or a bigger, you just actually list the vertices like that. So this is telling us that ABCD, and by the way, when you name something, it has to go in order around. You can go either way you want, but you couldn't say ACB or ACDB, right? You got to go A, B, C, D. Quadrilateral ABCD is congruent to this quadrilateral, JKLM. So ABCD, JKLM. So A corresponds with J, B corresponds with K, L and C, C and L, and D and M. Okay. Name all pairs of corresponding angles and sides. So angle D is the same as angle M, so they listed that there, and so on and so forth. Angle B corresponds with, and you can actually just look up here, oh, B and K, because they're both second, B and K. And then the sides, it actually works for the sides too. So check this out. Side AB is going to be the same as side JK. Ooh, yeah, I'm right. AB, JK. Side BC is going to be the same as side KL because they're listed perfectly in order. Could you list them perfectly in order if you were making a congruence statement like that? I hope you could. Let's try this. Let's see if you can do that right here. Don't really have my setup all perfect today. Sorry about that. All right. JLK, JLK, and TRS. I don't know which. Okay, I'm telling you right now, I'm giving you a clue. These two triangles, they are congruent. They are exactly the same. But let's make a congruence statement. Let's say JLK. Okay? You can just choose which way on the first one. But now when we say the second one, triangle JLK is congruent to triangle, we better get the corresponding vertices in the right order here. So does J, it's part of this big long segment, so it's either going to correspond with R or T, right? Is J going to correspond with R or T? Well, look, JK looks like the shortest side on this. So longest and shortest. Longest and, ST looks like the shortest. So J and T are corresponding. So I'm going to list T first here. K and S are obviously corresponding. So I'm going to put S last because K is last. And then in the middle, I've got my other one, R. So triangle JLK is the same as triangle TRS, which they told you right here. All right, now find the measure of angle S. Well, corresponding parts. Point number 2 here, okay? Corresponding parts of congruent polygons always equal each other. So, say my two hands are congruent. They're exactly the same. That one just flips over. This thumb, hello, is going to be congruent to this thumb because they're the corresponding parts. Right? And my two index fingers, and we'll stop at that. So what is the corresponding part with, we're trying to find S. So the corresponding part in this triangle is K, corresponding angle. So how can we figure out what K is? Well, we do 31 plus 25 is 56. And I know that the total angles is 180. So 180 minus 56 is going to give us 124. Am I right? Am I right? I think I am. 124 is what K is. and because that's the corresponding angle with S, K is in the middle, S is in the middle, then S is also 124. And I use the equal sign because this is an amount. It's a number amount. Whoa, man, how are we doing? 10 minutes. This, so maybe let's take a little joke break. Actually, I think I got some jokes right here. Yes, let me ask you this question. Why wasn't the geometry teacher at school? Why wasn't the geometry teacher at school? Because she sprained her ankle. Aww. Poor geometry teacher, she sprained her ankle. How ironic. All right. We took a little break because this next part, this is kind of a lot for one day, but you got it. It's all in your book right there. You can look right back at it, okay? This next part, we're going to get right to it. So, let me see if I can position this. We're kind of talking about triangles a lot right now, and that is okay. I think triangles are pretty cool. Congruent triangles. You can use special rules in the chart to tell whether triangles are congruent. These special rules we call theorems and postulates. When you get to geometry, which is what my 9th and 10th graders are doing right now, you're going to know these special rules as theorems and postulates, and you're going to have to use them to prove things. But for now, we'll just take a little stab at it here. So these special rules, the side, 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 or the side, or the angle, side, angle, you can use them to do what now? Get this. You can use them to prove that triangles are congruent or not congruent. So check this out. If you have a triangle and all of the sides are congruent, so like this is 5, that's 5, and that's 10, and that's 10, and that one's 15, that's 15, or something. If you can show that all 3 sides, corresponding sides, are all congruent or the same, then you can prove that that triangle is congruent to the other triangle. That's called the side, side, side. Now, what if you don't know all the side measurements? Let's say you just know this side measurement, and this angle measurement, and this side measurement. And in the next one, you know that side measurement, angle measurement, and side measurement are the same as those. Can you say, beyond the shadow of a doubt, that this triangle is exactly the same as that triangle? That this one's congruent to this one? Do you have enough information? The answer is yes. Side, angle, side. If you've got side and then an angle and then the next side, then that works. Now check this out. If I do triangle, triangle, and let's say I know that side and that side's the same, and this side and this side's the same, and then this angle and this angle are the same. Are those congruent? Congruent? The answer is, there's not enough info, Mr. Anderson. Correct, student. There's not. This would be an example of side, side, angle. And there is no such thing. Or angle, side, side. No such theorem to prove triangles are congruent. So notice the order that it's in here. Side, angle, side. Side, angle, side. Okay, last one. If you've got an angle, corresponding angles are congruent, and then sides, and then another pair of angles congruent, you can say that those triangles are congruent. So what does this look like in an actual problem? We better do 1 or 2 of these. Let's see. Explain how you know. Check this out, number 13. Explain how you know the red triangles in the kite are congruent. Red triangle, red triangle. How do you know they're congruent? Ooh, this is fun. This is fun. This one's 5 and this one's 5. Okay, so you could visualize in your head. Forget about these orange ones. Okay, they're not going to matter. That side's congruent to that side. Ooh, and check this out. These red triangles, they share a common side here. And so that's going to be congruent because it's the same as itself, and it's part of this triangle and that one. So we've got side, side. Can I say that this last corresponding side here, that they are the same as each other? Could I just up and say, yeah, they're the same? No, I don't know if they're the same. So what else can we figure out here? We're going to have to think about some angles. Ooh, check this out. If that's a right angle, doesn't it mean that, if you got two lines and they intersect like this to form one right angle, then actually all the angles are right angles. Can you see that? So I've got that angle is the same as that angle because they're both right angles. So what theorem is that? Side, angle, side. Side, angle, side. Boom. Explain how you know. Your answer can just say SAS. Explain how you know the red triangles are congruent. SAS. That's it. Actually, you should probably say side, angle, side because, and I'll just say this instead of right, because right angles are the same and they share a common side. Okay, so let's do maybe one more down here. Number 15. Well, that's a side, side, side. Let's do 17. 17. Explain how you know the triangles are congruent. Then write an equation and solve for x. How do we know that these two triangles are congruent? Angle, side, angle. Is that one of the theorems? I better flip back real quick. Oh, yes it is. It's down here at the bottom. You can't really see. Angle, side, angle. Okay. So, angle, side, angle. Angle, side, angle. Then write an equation and solve for x. Well, if I know that these are congruent, and I know that this vertex up here is corresponding to this vertex, right? Then I can say x, oh, this gets weird. Check this out. X equals this one, 2x minus 24. Yeah, because they're corresponding parts, and so they're the same as each other. So x equals 2x minus 24. So now let's just solve it. I'm going to add 24 to both sides. So I got 24 plus x equals 2x. Now I'm going to subtract x from both sides. And 2x minus 1x just gives you x. So x equals 24. Solve for x. That's what we did. I'm going to do one more because I think this is kind of hard stuff. So let's look at 15. How do I know these are congruent? Side, 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 side. So side, side, side. Side, side, side. SSS. Okay? That's how we know they're congruent. Now, how can we solve for x? Well, this side is congruent to this side. So this one is 5 because that one's 5. And this one is 4, and that one must be 4, because those are the same as each other. That's why there's 2 congruence marks for each. So this one must equal 4. So x minus 6 must equal 4. Well, what minus 6 equals 4? 10. X equals 10, right? 10 minus 6 is 4. Got it. All right. In summary, let me just remind you. When something is congruent to something else, the order that the vertices are listed, such as quadrilateral ABCD is congruent to quadrilateral TPON, the order matters. Make sure you place yours in the right order so corresponding vertices are in the same position. Okay? Also, congruent symbol is different than the equal symbol. Use a congruent symbol if you're talking about shapes. Use an equal symbol if you're talking about amounts, like numbers. And finally, you can prove triangles are congruent in 3 different ways: side, 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 and angle, side, angle. Ooh. And you're going to have to wait till geometry to learn a few more, because there are more. So, until I see you again, we'll talk to you later.